Hey folks, how we doing? Let's take a look at page 488, example 3. A 2009 survey said that 34% of teenagers texted while driving, and now we're wondering if it's different than 34%. So we do a little sample of 1,200, and 353 say they text while driving. Okay, so we want to see if things are different. So the whole idea is they're saying, hey, you can use a confidence interval to shortcut the whole two-tailed test. What's a two-tailed test? So go back in time. Our alternative hypothesis, the H1, or sometimes called the HA, in this section is always going to be either less than, a greater than, or does not equal. So if it's a less than or greater than, we call that one tail. If it's a less than, you see how it points to the left tail, points to the right tail. And then if it's a does not equal symbol, it's two tails because you'd be shading on both tails. Okay, so once again, what we're going to see is that we're going to do our hypothesis test, but what we're going to show is that a confidence interval is just a shortcut to a two-tailed hypothesis test. And then in future sections, we're going to learn how to do confidence intervals to shortcut a one-tailed test, either left tail or right tail. But for right now, they're warming us up with the idea of a confidence interval is just a shortcut to a two-tailed test. A two-tailed test because our alternative is going to be H1. So let's just do the standard 6 questions of a hypothesis test, and then we'll do the confidence interval, and I'll show you how we shortcut the whole system. So they gave us the null and alternative, but if you reread the problem, it says 34% of teenagers text while driving. Has it changed? Okay, so P is equal to 0.34, and it's not saying is it more or less. We're saying has it changed? Is it different? So then the alternative would just be that P is different than 0.34. So because of that symbol, it's a two-tailed test. And our P hat, what did we actually, when we took a survey, what results did we get? 353 out of 1,200. So I'm just going to throw this into my calculator using a 1 prop Z test. Grab my calculator. Okay, let's scoot this over a little bit. On, let's see, clear, stat, tests, 1 proportion, 1 prop Z test, enter. What's the P naught? 0.34, enter. The X, 353, enter, N, 1,200, enter. Choose that symbol, two-tail, so enter. Slide down to calculate, enter. And you see that we get a test stat of Z equal negative 3.35, or negative 3.35, negative 3.35. That's a p-value of 8.03, E negative 4. So hopefully you remember how to deal with that. That's going to be equal to, move the decimal 4 places over, 0.123,803. So my p-value is a really, really tiny number. So hopefully you're cool with scientific notation. We talked about it before. So move the decimal 4 places to the left. So that would give us this. This number is way less than alpha. Reread the problem. They said, they said 95% confidence. Okay, so go back in time for 1 second. It'll all make sense in a second. So when they say 95% confidence interval, that's going to be equivalent to an alpha, as long as it's two-tailed, a little confusing, I know, of 0.05. In other words, if there's 95% in the middle, how much is left over? 5%. Oh, it has to add up to 100. Okay, guess that's making sense. Okay, so my p-value is less than my alpha, so I would reject HO. Here's HO. Reject it. Bye-bye. Evidence suggests the HA. Evidence suggests the HA. And then just put the HA into words. Evidence suggests the proportion of teens that text is different than 34. Is different. Symbol is different. Different than 0.34. Ta-da! Okay, so that's doing the hypothesis test. Now, if we make a confidence interval, you'll see that what we do is we can go straight to our statistical conclusion really quickly. So, another piece of paper here. The p hat was x over n, which was 353 over 1200. So now let's make a 95% confidence interval. So remember, 95% confidence interval is equivalent, an arrow, is equivalent to alpha 0.05 two-tailed test. Okay, so let's make a 95% confidence interval. So again, I'm just going to go to my calculator. That's 1 prop z interval. Int. Okay, so I go to my calculator. Let's see. Clear. Stat. Tests. Go down to 1 prop z int. 1 prop z int. Okay. And then are the numbers still there? Oh, that's nice. 353. Cool. N of 1200. Cool. Change that to 95. Enter. And it gives me a confidence interval of, all over the place here, what was that? 0.26839. Focus. And 0.31995. So I pet the calculator so that it focuses better. Okay. So let me write that down. We're almost done, folks. Hang in there. We're doing well. Okay, so that is a confidence interval of 0.26, I'll round it, 84, comma, 31995. 31. What if I don't round? I don't want to get into a discussion about rounding. 0.26839, comma, 0.31995. You see how that's going to be a chain reaction? So I'm just going to avoid that conversation. Okay, so now we're getting there. Remember, the null hypothesis was we were wondering, back in the past, 34% of teens were texting while driving. Is it the same or different? Or is it different? Okay, so we look at the number in our null. Is it in our confidence interval? Our confidence interval goes from 0.268 to 0.319. No, 0.34 is way out over here. It's not in that interval. Oh, so this idea is not in our interval? Oh, so this idea is not good. This idea in our null is not good. Why don't we reject HO? Aha. And isn't that what we said we needed to do right here? Reject HO. Aha. So a confidence interval is just a shortcut, or can be used as a shortcut, to a two-tailed hypothesis test. Almost 10 minutes to explain that. Okay, so that means I over-explained it. I hope that makes sense. And then you'd have the same conclusion in plain English. So you get the same statistical conclusion, which gives you the same conclusion in plain English. Yay! Oakley doke.